So now we're looking at the second page of 2.7, this number 1 here on the left side. We're given this equation, and we want to write our proof, right? And again, how do we write a proof? We start by changing any congruency statements to equations using definition of congruence. Then if any midpoints are given, we change them into equations using definition of midpoint. And then lastly, if there are 3 points on a line, we create an equation using seg-adpos. If there's 4 points on a line, we could do seg-adpos 2 times, right? On the left 3 points and the right 3 points. And then lastly, now that we have all our equations, we're going to use substitution to get to the proof. So we are here. We have the first statement here. That's going to be given, of course. And then from there, we have nothing left, right? We don't have midpoint. We don't have any congruency statements. So now we're going to look at the figure, right? Can we turn this figure here into an equation? No, because there's only 2 points. Seg-adpos only works when you have 3 points on a line. So we're looking at this part of the figure, A, B, C, and we could turn that into an equation using seg-adpos. Okay, so let's go ahead and do that. So it's AB plus BC is equal to AC. Right. So how does seg-adpos work? It's first part of the segment plus second part of the segment equals the whole segment. So AB plus BC equals AC. We got that there. So now we've gone through all the steps, right, in the how to write a proof document. And so now we use substitution to get to the prove statement, namely this here. Right? And so now if we're comparing our statement 2 with the proof statement, what's the difference? It's this here, this BC. I'm sorry, hold on. Okay, there we go. It's this BC right here, right? That BC right there needs to turn into a DE. And so can we turn that BC into a DE to get to the proof statement? And yes, we can, right? Because in order to turn this BC into a DE, we need to have an equation that says BC is equal to DE. And do we have it? Yes, we do. It's statement number 1. BC is equal to DE. That means anywhere I see DE, I could put BC. Anywhere I see BC, I could put DE. Right? And so I'm going to take this DE right here, and I'm going to put it right here in the place of BC. And I get this equation, part 3. Right? And so that was substitution. And we're done, because that's the proof statement. So substitution is I guess it's a property, an algebraic property, that you must learn how to master in order to write proofs.